In this video, you're going to learn about finding area involved with circles inscribed in and circumscribed about regular polygons. So this problem says a regular hexagon is inscribed in an angle with a radius of 4 feet. Find the area of the shaded region shown. Give the exact answer. And it says do not approximate pi or any square root, which means you're not going to really probably have decimals in your answer. It might be a bear cat of an answer, but it wants it in exact terms. So don't round and don't and make sure you simplify all your radicals, I guess is what I'm saying. All right, so we need to find the area of the shaded regions. What I want to do is I'm going to find the area of the circle. And I'm going to subtract the area of the hexagon. Okay, in order to find area of a circle, I'm going to go pi times the radius squared. And to find the area of the hexagon, I'm going to go 1/2 times apothem times the perimeter. So I'm given the radius in this diagram, but I need the apothem and I need to find the perimeter. So what I'm going to do, I'm going to focus really big in on this circle. I am looking for the apothem and the perimeter. And what I need to do is I'm going to draw a line from each vertex or each point here to the center. And I see that I have 1, 2, 3, 4, 5, 6 triangles. So if there's 360 degrees in a circle, and I have 6 triangles here, that means that 360 divided by 6, each of those triangles has a 60-degree measure. Okay, and what I want you to think about is if this is 60, if this is 60 degrees here, and I cut that in half, then half of it would be 30 degrees. So let's look at this triangle. This would be 30 degrees, this would be 60, and this would be 90. So what we have here, we have this hypotenuse is 4. And to go from hypotenuse to the short leg of a 30, 60, 90 triangle, we would divide it by 2. So this side length, or this short leg here would be 2. And then the long leg would be 2 times the square root of 3. So that's using special right triangles. So let's put this back in here. So pi times the radius. So the radius was given to us. That's 4 squared. And that's the area of the circle. And we want to subtract the area of the hexagon. So the area of the hexagon is 1/2 times the apothem, which here is 2 square roots of 3. And the perimeter. So I know that, I'm going to zoom back in here. I know that this little side is 2, which means the whole thing is 4. So if this side length is 4, and we have 1, 2, 3, 4, 5, 6 side lengths, 6 times the perimeter would be 6 times 4, which is 24. I'm going to come back out here. So our apothem is 2 root 3, and our perimeter is 24. So this question says to give the exact answer. Do not approximate pi. So to get this in terms of pi, we're just going to go 4 squared, which is 16 pi. All right, and now for, we're going to subtract here. What we're going to do is we're going to focus on all the numbers that are not the square root. We're going to do it, so 1/2 times 2 times 24 is going to be 1 times 24, which is 24 square roots of 3. And that doesn't look like a real answer, but that is the answer that they want you to type in. 16 pi minus 24 root 3, and then we're finding area, and so we're going to go feet squared is our units for area. And that's your final answer. So the hardest part about this, I think, is probably using the special right triangles to solve for the apothem. I think that's the trickiest part. I think the next hardest part would be leaving this in terms of pi and radicals. It's kind of a foreign thing because we're taught just to reduce and simplify, but this is the exact thing we want. We're going to try one more of these, and this one's a little bit different than the last one, because if you look at the last one, the outer shape was the circle and the inner shape was the polygon. So the circle was on the outside, but on this one it's a little different because the circle is on the inside. So what we're going to do on this is a little bit backwards. We're going to go area of the triangle minus the circle. Okay. So the equilateral triangle is circumscribed about a circle with a radius of 12 centimeters. Find the area of the shaded region shown. Give the exact answer. Do not approximate pi or any square root. So to do the triangle, we could use 1/2 times base times height. And since it's an equilateral triangle, I'm going to use the area of a regular polygon formula, 1/2 times apothem times perimeter. And then we're going to subtract the area of the circle. So the area of the circle is going to be pi times radius squared. All right, so let's zoom in on this triangle. And I'm gonna so there's 360 degrees. Oh my goodness. Minus or divided by 3 would be 120. So this would be 120 for the whole thing, and for just half of it, it would be 60. So I know this is a 30, 60, 90 triangle. And here my apothem is 12. It's the radius of the circle, but it's also the apothem of the shape. Okay, and so I'm just going to use that. I don't need to find the radius of the shape itself. So this would be 24, but we're not going to use that. That's not helpful. We do care about this side, so this would be 12 times the square root of 3. And if we're looking at the entire side, the whole side would be 24 square roots of 3. And that should be enough to find everything we need, right? So triangle 1/2 times the apothem, which is 12, times the perimeter. And so we know that one side is 24 root 3, and there's 3 sides like that. So I'm just going to go 3 times 24, which is 72. It would be 72 square roots of 3. All right, that's our area of a triangle formula. Minus pi times the radius of the circle, which is 12 squared. Now this tells us to give it the exact answer. Don't approximate pi, don't approximate square roots. So it's going to be a weird looking answer, but that's okay. That's what I'm going to do is I'm going to focus on the numbers that are not the square root. I'm going to go 1/2 times 12 times 72, which is 432 square roots of 3. And then to do this in terms of pi, I'm just going to do the 12 squared, which is 144 times pi. And that's my answer. That's the exact answer. It looks unreal, but that is actually what we're looking for. And we're going to label this in centimeters squared because we're looking at area of the shape. So this is our final answer.